sort. What is the time complexity of the bubble sort? What is the time
n
complexity?
square, n square.
Time complexity is n square. So for each of the sorting algorithms that we'll talk about what is the time complexity, and we'll talk about how many swappings happen. How many swapping will happen in the case of the bubble sort?
Okay, so it will happen like n minus 1.
N minus 1 only sorting. Do you guys think that? What do you guys think? Like, is it like n minus 1 swapping that will happen, Paritosh?
A few moments later.
Okay. Let me quickly write the bubble sort algorithm. Right? This is a bubble sort algorithm. This is what you guys have read. So why it is called bubble sort? Because every time the larger element will try to bubble from the bottom and will go to the extreme right. Just how when you boil water, the warm bubbles from the bottom and goes to the top. Similarly here, if you see, this is the outer loop, and every time inside the inner loop, if any element is greater than the next one, it will try to move to the right and will keep bubbling to the right move point. So at the end of that, every time a larger element will try to move from the left hand side to the right hand side, one step at a time. So that is why I say that it bubbles through left to right, and we call it as a bubble sort. Right? Everybody is in sync with this bubble sort algorithm. You have read the same thing.
Yeah.
Right. Now to tell me how many times the swapping is happening. How in the worst case, how many times the swapping will happen? What do you tell me? Approximate total number. It will be like linear. It will be quadratic. How much? It
n square.
It should be n square. Okay. Manoj, you were saying n, right? And as per the Manoj, it is n. How about Srinivas, you?
It's n square, I think.
And how about the Vivek? N square.
Yeah.
Okay, so I think the n square is right. Manoj, I don't understand. Why did you say n? You have any logic for that?
Yeah, you have a first, suppose we have a first element that is 0th index, and we have to move in the worst case I'm saying, so that we have to move it at the n minus 1 place.
Yeah, so I think I'll give you example and it will clear too. Suppose my
Okay.
is like this 5, 4, 3, 2, 1. Okay. So first time what happens is that I'm here. Like I'll try to compare 5 and 4. So 5 and 4. What first swapping I did 4 and 5. It happened now, and it became like 3, 2, 1. Now the second swapping happened, right? So 4 and 5
Yes.
and it became 3 and it became 5, and then
Yes.
2 and 1. Then again happened 4 and
3, 2, 5.
2 and then 5
5,
and 1 happened,
1.
and then again it's 4 and then 3 and then 1 and then 5 happened, right?
5,
Now
yes.
again when I started, then again the 4 and 3 will happen. I know.
Okay. Got it.
2 then 1 then 5.
Vishwa,
Yeah.
Achha.
I have one question I can ask you right now. Like in
Yeah,
this, see, my question is like, suppose like if you compare this bubble sort only, just take two examples. Suppose if there is one array which is already sorted, okay. Now in this case, it won't be the time complexity won't be n square right here, because the thing is already sorted. And
even if the array is sorted, you'll try to check this condition. The swapping will not happen. That is true. In the case if the array is already sorted, in that case the number of swappings will be 0. But we will go inside the loop. It will check for that condition. So the time complexity will go of n square itself, even in the case if you are given your sorted array.
But one more thing, like suppose if there is a algo and it is having best case and worst case, so there might be two time complexity coming out of that. So
normally whenever so yes, so any algorithm has 3 kinds of time complexity as such. One is known as the best case time complexity, another is like worst case time complexity, and the third one is known as the average case time complexity. Right? Whenever we have to write an algorithm, we always think about what is the worst thing that can happen and how can I improve it. So time complexity we only consider about the worst case time.
Yeah, okay, fine.
So this is the code for the bubble sort. And a question for you guys now. Please pay attention. as right now Paritosh asks a question that what happens in the case if the array is already sorted or if the array is nearly sorted. With this current implementation, even if the array is sorted, if I call a bubble sort, the time complexity will be O of n square, right? Can we make any change in this particular function of the bubble sort so that it improves my time complexity? I may not have to run the loop O(n) square times to figure it out if the array is already sorted, or even if the array is say nearly sorted, like almost almost all the elements are sorted except few elements. Like for example, it is like 1, 2, 3, and then it is like 5 and 4. So this is almost sorted. Only one element is misplaced, right? So in this case, again, I don't want to have a time complexity of quadratic. I just want to solve it very fast. Can I do something in this method called bubble sort to improve the time complexity? In the case if the array is nearly sorted, or if the array is already sorted, can I do something in this bubble sort so that the time complexity improves? Can you think of something?
A few moments later.
Before entering the for loop, if we just check that the current element and the next element is greater or not, and if it is not, then only get into the second loop.
So here you want me to put anything, or here you want me
No,
to?
no. After this, yeah, after this.
What do you want me to do?
So just check whether the current element and the next element.
So current element is I. This is the last element. I don't have the access to the element in the
Okay.
last. The current element is I here now.
So if you increment the current element I plus 1 like that.
So this is the last element, no? This is the last element. So in the outer loop, we are going from the right to the left, and in the inner loop, we are going from left to the right.
Okay.
So in that case, right, we could say that array dot length minus 1 is always greater than array dot length minus 1 until we meet a break condition.
So what you tell me? What should I write?
I'm saying like array dot length minus 1 greater than
Array dot length minus 1. So are you giving me this logic based on this particular input? Because here it is like this. It may not be like this. It may be like this also. So don't give me a logic specific to this particular problem. It can be like this. What happens in that case?
Okay. Then
Your logic was specific to that part. Your logic should not be dependent on the input. It should be independent of that. Cool. I'll try to give you guys. And so going onwards, my suggestion is that whenever you are reading any algorithm, right, and this improved bubble sort is not there on the internet. Mostly you will not find it. But if you understand the algorithm better, if you try to focus the algorithm better, you'll get many additional information out of it. So for example, in this case, can you tell me which piece of the code is determining that the array is not in the order? Can you tell me, if you just look at this particular piece of code from here to here, which portion of the code can tell me that okay, there is some misorder in the code? Can you tell me?
the if
Condition, right? The if condition. Now suppose if I tell you that this internal loop works for complete from the j is equal to 0 to j equal to y, and in that none of the time my if block get called, can I say that all the elements are in order?
yeah.
If I say that you run the complete inner loop completely, full inner loop from j equal to 0 to j equal to less than I, it ran for the complete one full iteration, and in complete full iteration, none of the time this if condition was hit, if condition was true, then can I say that all the elements are in order?
Yes.
And if all the elements are in order, in that case it is already sorted, right?
But again, it's running 2 times, right? It's running
So,
n square times.
yeah. So this is what intelligence that we have to brought in. So what we can do is we can put Boolean is already sorted equals to true, right? And only if it goes inside this, I'll set that Boolean is and once this whole complete thing runs away, I'll check it is already sorted. And if it is true, what I do, I can simply break the outer for loop. So in that case, instead of a quadratic, it will run only once, and the time complexity will be how much? It will be O of n in that case. Did you get it?
Yeah, but Biswa, I have one doubt. So this
Yeah.
will only work if it is already sorted, right? So
Yeah.
if it is a nearly sorted, we spoke before, like if the last element or suppose 3-4 elements are already sorted and one we have to just swap. So in that case also it will go for n square, right?
So this just give you a little slight improvement over
Yes,
the
yes.
previous one. Okay, what I'm saying is it has not made this algorithm a linear time algorithm. It's still
Yes,
a
yes.
worst case time complexity of n squared itself.
Uh,
But in certain situations, in certain problems, so suppose only the condition was like this 2 and then 3 and maybe 5 was here and then 4 was here, right? So in this case also you'll get a better time complexity because in the first iteration itself the largest will go at this point. So after the first iteration itself the situation will be like this 1 2 3 4 and 5. So after one iteration it will come to this, and the second iteration it will know that it is already sorted. So it will again give you a near linear time complexity. Even if it is like this, even if it was like 5 was here also, even if 5 was here also, and you have condition like this, right? So all the other elements are sorted except the one element. So in the first loop itself, the 5 will go to the largest because the bubble sort, what happens in the largest element always goes to the right. The 5 will go to the right after the first iteration. And in the second time when it comes back again, it will see that it is already sorted. So what I'm saying is that with this particular one extra boolean that you have added, you have tried to improve the time complexity of the bubble sort in certain situations when you have already sorted array, when you have a nearly sorted array. Okay.
yes, yes.